Hey, and welcome to another episode of Lexx Education, the comedy science podcast where comedian me, Laura Lexx, tries to learn icky, sticky science from her marvellous brother Ron.
Hello, I'm Ron.
Hi Ron, how are you?
Yeah, wonderful, thanks. Time of my life.
Look, well, listen, we're doing an intro for this, and it's mid-January now, but it's actually still the 16th of fucking December
It's
for
now
us.
10 to 5.
We just spent an hour and a half recording 3 weeks ago's episode. We're livid with each other, but we're trying to sound bright and sparky. But we're back off our holidays, so if you've wanted to get in touch on social media for a shout-out on the pod, do it this week, because next week we're back caught up. You'll hear all our tales of being on holiday and how our Christmases went. Ron, how do you think Mexico went? What are you going to talk about? Did you get the poops?
I will get the poops. I'm going to eat taco after taco after taco. I'm going to see... No, I've seen the Atlantic Ocean before. I'm not going to that bit of Mexico. I'm going to leave Europe for the first time. That's fun. Going to go to...
Europe.
No? Have you?
Yeah.
Where have you been?
Dubai.
Oh, yeah.
Caribbean.
When have you been to the Caribbean?
Before you were born, Mum and Dad used to take us on really cool holidays.
Oh, yeah. Yeah, I never left Europe before. I'm going to the US of A.
Sweet. Is that like a stopover on the plane?
Yeah, I think Houston in one direction and then sunny Miami on the way back.
Oh, nice. Yeah, I remember stopping in Maine on the way to St. Lucia, and I got a troll doll from the airport.
Nice.
Yeah. So anyway, that's what we assume Ron has been up to.
Laura, how's your
died,
Christmas
Ron.
been?
My Christmas was delicious, but I've been in
It was a bit
Inverness.
much, wasn't it? It was a bit
Yeah,
much.
probably got sad at some point because I haven't got kids. Then I had a cake and cheered up. That sounds like me. Woo! Then I went to Inverness, had a great time. It was very cold, and there were cute puppies there.
Probably got sad again for a bit.
Probably got sad again because I haven't got kids. And then, that's then I went for a walk and cheered up. Let's call it that, shall we? I'll tell you about a row I had with Tom that seems inconsequential as soon as I start telling you about it, but at the time, felt like we were about to break up. Then I got sad about that, and then immediately cheered up. Okay, there we go. So enjoy the episode. We're back to plant biology today, aren't we, Ronnie?
Xylem, phloem, transpiration.
Transpiration. Enjoy.
That was a bad physics topic.
But it's over now.
There's always more.
Don't worry about physics now, Ron. It's biology today. Is it nice biology?
We're carrying on with plants.
Well, we're doing plants. That's fun.
Remember?
Nope.
Don't remember talking about leaves?
Oh, yeah, waxy leaves.
Waxy cuticles on the leaves. Today, the section Stomata. Today, the section that we're doing is called the plant organ system.
Brilliant.
So, Laura, just a couple of recaps. So,
That
Laura,
was an organ. I was imagining like a Venus flytrap playing an organ.
yeah, I'm quite a switched on guy, so I managed to get it.
Switched on guy. He's a switched on guy. Do you want a switched on guy? Tough, he's already with girlfriend of the podcast, Judith.
Lexx Education, the musical.
Oh, let's do a musical episode one day.
I could teach you music.
I already know music. Listen to me. There is...
Clap a beat. Clap a 4/4 beat for the listener. This chair's so loud.
Yeah, I don't know why you always use that chair.
Oh, because I can't be bothered to get another one. But
Why don't you just always have a nice, good chair?
Because the other ones are low. They're very low.
but you work from home every day. Invest in yourself. Get yourself a nice comfy chair.
This chair is comfy. It's just loud. It's not that comfy. It looks nice though. My
I've got a
Scandinavian
lovely
office.
comfy chair. Very quiet.
Isn't that my chair? No, Tom uses my chair.
Tom's got a white chair.
What happened to the chair I gave you?
What chair?
I gave you a chair. I gave you an office chair.
Oh, is it that one over there?
Can't see anything but the wall. Keep going. Maybe go the other way. Because it seems like it's more than 180 degrees that way. Or is it under all of that crap?
It's behind the poofy thing in front of the shelves.
It's so hard to tell on this small screen from that distance, to be honest.
What kind of chair did you give me?
It was an office chair.
Black one?
Yeah.
Yeah, I think it's that one.
I thought you couldn't get it up into your office. That's why Tom ended up using it for a bit.
I don't know, and this isn't interesting content.
Anyway.
I bought myself this lovely chair off Viking Direct, and it's comfy, and I feel like an executive when I sit in it.
That's nice. Right, let's get into it, yeah? Plant organ system. We're just going to do a couple of recaps, make sure we're all on the same leaf.
Mm-hmm.
Nothing for that. What's an organ, Laura?
An organ is I know this. An organ is a collection of tissues.
Ding. Nice. Maybe just run me through the hierarchy.
A cell makes a tissue makes an organ makes an organism. It's up to the organism if they want an orgasm. That's a slightly different thing.
So close. You missed out organ system, but I liked it a lot. Not going to detract from it.
Okay, brilliant.
Okay, what's a plant?
A plant is a... Hey. You know it when
Hey.
you see it. A plant is an alive thing that needs...
No,
What do you mean, no?
it's not really.
Plants are alive?
Yeah, very little taxonomy is done via the needs and desires of the animals that they're talking about.
What do you mean?
Like a squirrel is not defined by its lust for nuts.
Lust for nuts. No, wait. Yeah, but you know that's just my language. When I say like, oh, it likes or needs, a scientist would say it requires.
Okay, you finish the sentence and then I'll shoot you down.
Energy from the sun. It feasts off energy from the sun, vitamin D.
Photosynthesis, all right, I'll give you that one actually.
Yeah.
And
It has cell walls.
I might go get a different chair.
You do you, buddy.
You ever think, all right?
Cell walls?
Yep. I don't have Bluetooth headphones. So...
Oh, that chair's nasty.
You're nasty.
I wish this was a live episode because then I'd get listeners to whisper me answers now. Be like, hey, guys, I've written down last time. Oh, I did have organ system in my little thingy last time. Plants, energy from the sun, chloroplasts. Maybe he wants me to say chloroplasts. Check that one out with him. Yeah, I'm going to say...
Huh?
Oh. The weasel is squeaking. The thing about Ron's face is it's always worried.
I really need to sweep under this desk. It's gross. Yeah. Look at this guff I just picked up on.
Oh. Is that gnocchi hair?
Mainly, yes.
She's the worst.
She's a shedder.
Hey, chloroplasts and photosynthesis.
Chloroplasts do photosynthesis, yes. And the cell wall, that was all I wanted you to say. Grand. Well done, Laura.
Yeah! Well done, the big book of learning. So full of brilliant ideas.
She's making a shit book of science.
I don't think it's a shit book if it's working.
I think it's a shit book if no other human being in the world could pick it up and use it.
I'll rewrite it for the masses. This is just a first draft.
Is that going to be book number 3? Klopp actually pivot the shit book of Laura.
Somebody does want me to write a memoir, but I don't think I've really done anything.
Yeah, have they met you?
Yeah, what's it going to be? You can't sing in a memoir.
Then I met a pig in Minecraft. It was a nice day.
Day 2, worried. Day 3, did some more worrying.
Day 3, worried with pig in Minecraft.
Day 4, discovered a podcast that blocked out the worries. Day 5, oh no, I've already listened to all of that podcast. It's time to worry again.
Day 6, watched the same show because that was the last time I was not worried.
Yeah. Ah, it's good times.
Xylem.
Xylem and phloem.
Remember which ones the xylem was?
I can try and do this without looking back.
Because that's not remembering.
I've told you before, and I'll tell you again. I shan't be remembering. Xylem, I think, is the one that goes one way. Xylem takes NRG, chemical, chlorophyll.
Don't just say things. Does energy only need to go one way in a plant?
No, but the other one takes it both ways.
Yeah. Your point being?
What's it taking then?
What's like, you own plants. What's the one thing you give them?
I thought the phloem did the water. The water goes up.
No, xylem does water. Water goes up.
Oh, how can I remember that? A xylophone is fun, and so is a water slide. Okay. The problem with my shit book of science is that there's a lot of crossover that's on a lot of the same pages.
Yeah. We do a lot of doubling back. Kind of the book equivalent of like reality TV where they're like, last time on.
Which I know, I always skip that bit on reality TV because I just remember it. But I guess
You're
for
often
some...
not listening when I recap things as well. It's kind of the same.
I'm always listening to you, Ron. It's just... I don't know how to describe it. It's like if you don't read sheet music, when you listen to music, you're just hearing it. You're not imagining the sheet music to go along with it. And sometimes listening to you talk about science is like that because I can hear that you're talking. You've got a nice voice. I like you. But what you're saying is just gibberish.
No, but that's where I get frustrated because you're not actually a swamp brain. What happens is you there's like a switch in your head where you go, oh, this is science, so I'm gonna not take it in under the assumption I won't get it.
No, I don't think I do that. I think sometimes if I'm going to understand it, I've got to understand it, and then there's too much stuff around everything.
Yeah.
you have to know all of it for any of it to be logical. You can't understand it in isolation.
This is why I could not answer when you asked me what was a science thing you could learn in a month.
Yeah, I'll have recorded it by now, but basically I'm going to be on Celebrity Mastermind, and they were like, oh, so maybe you could do a science thing as your specialist subject. And I was like, uh-huh. Yeah, I've got 1 month to do the cramming, and I've already been doing this podcast for like 5 months. What could I learn in a month? So we didn't go with science in the end.
What did you go with?
History of alternative comedy.
Oh, yeah, it's on brand. You should have done glass. Right, where were we? Xylem. We were trying to come up with a way that you could remember xylem is for
A
water.
xylem phone is fun, and so is a water slide.
What about alphabet? It goes W, X, Y, Z. Xylem starts with an X and a Y. W is for water. X, Y, W, X, Y, Z.
No. A xylem phone is fun, and so is a water slide.
Okay. So, what we're gonna be talking about basically is how these things are adapted to carry out their function. So, what are some ways that you either know or imagine a cell could adapt itself to be good at being a water slide?
It's made of lignin, which is a watertight thing around the edge, so no water gets away.
Have you Googled this?
No, we did this last time.
Okay.
I have learned it.
Wow, well done. Yes, that is true. That's one of them. So the walls are strengthened by a substance called lignin. Like you say, this is waterproof. It strengthens the plant, but also makes the xylem waterproof. Now, this process, the process where the xylem cell goes through, hollows itself out and coats itself in lignin, this is called lignification. Lignified cells are what we call wood. And for no specific reason at all, I'm just going to tell you that the melting temperature of lignin is 170 degrees.
I think you want me to write that down. No, wait, you're telling me that wood melts.
I'm not saying anything. I'm not weighing in on that debate again. I'm just saying that we call lignified cells wood, and lignin melts at like 170 degrees.
Ronnie, Honks, you fucking genius. You've cracked it. Now I believe you. Wood can melt.
Grand. Okay. What do you think from the last time the other adaptation that they've done is?
They had some kind of thing where they had like a perforation between the cells.
No, that's the other one.
Oh.
In fact, the opposite of that. They don't have cell ends so that the water can...
They're just tubes.
They're just tubes, yeah.
Okay.
And xylem are dead. They're not alive. They're cells that have sort of sacrificed themselves to become tubes.
Okay. The cells are dead, and they've made themselves into tubes.
Yep.
Okay. Yeah, I remember this. Is this the recap, yeah?
No, this is the lesson.
Okay, cool.
Yeah. Okay, so then, so that's xylem. We're just kind of talking about cell adaptations. We get that, okay?
Mm-hmm.
Now we're going to think about phloem.
Okay.
We remember what they're for.
Phloem is for moving energy from the leaves where it's been created down into the tubers or the roots or the storage, or, if it's needed, back up and around the plant to be used in the organs.
Swell, exactly, yes. Well done. So it's and you know how that energy is transported?
No.
In the form of sugar.
Sugar!
Yeah.
Yes, okay, yes.
Sugar is essentially the end point of photosynthesis. It makes glucose, what we all know and love. The more sun, the sweeter things are. I was recently in the wine-producing region of Austria, the Warschau, where they were telling us about the wine, and like the vineyards on one side of the valley produce a much sweeter wine than the vineyards on the other side of the valley because they get more sunlight.
Yeah, delicious. My homemade tomatoes, they are really sweet because they're slow grown at home in the sun, not like force grown in a hot
Exactly. So the process of moving the sugar up and down, that's called translocation.
Translocation. Oh, I made the dog bark. I'm such an
She
actress.
hates vampires.
She probably would.
No, there's a vampire. So translocation is an active process.
Okay.
What does this mean?
That means the plant is using energy to make it happen.
Absolutely. Can you infer a difference between xylem and phloem based off that fact?
Phloem is a passive process.
Don't just say things.
I didn't. That was a genuine inference.
Oh, but we're talking about phloem, and I just said it was active. It's...
Oh, xylem is passive then.
Xylem is passive, yes, but another difference between the cells themselves, not necessarily what they do. If one is a passive process and it's dead...
So the cells in phloem are alive.
Exactly,
Okay.
yes. So they are not just tubes, basically. As such... These are the ones that have, like you said, the sort of the civvy plates in between them.
Okay, yep.
Phloem are actually made out of two different types of cells. Okay.
Ooh. And they are at bitter war with one another. Two cells, both alike in dignity.
Shakespeare.
The internet broke up so badly as you said that. Shakespeare.
Shakespeare. So the one is called sieve tubes.
Sieve tubes.
Sieve tubes. Sieve.
Like-
Sieve.
Like a sieve in my kitchen.
Yes. Sieve tubes.
Sieve
Specialised.
tubes. That sounds very sci-fi, doesn't it? That's
Sieve
like
tubes.
There's this really great series of books by Becky Chambers, Record of a Spaceborne Few, and I can't remember what the other ones are. And it's some of the only space stuff that doesn't freak me out, but it's lovely. And they're always the technology in that sounds like it could be one of those sieve tubes. The sieve tubes were how we got the globular out of the walls of the ship and turned it into food that the humans could eat.
These sound like weird books.
They're great books. I tell you what they're great for, Ron, is there's not much plot. It's 98% world building. And I am here for that. I know that most people love plot. I take it or leave it. I just like living with some nice people for a while.
Yeah, no, I really enjoy the world building things. That's why I really like Philip K. Dick's books.
Dick.
Yeah.
K. Dick?
Philip K. Dick. Sieve tubes, specialised for transport.
Oh, last night I saw somebody in town dressed up as a sim.
As in, like, they had a little crystal floating above their head.
Yeah.
All right. So, yeah, they're specialised for transport.
I just...
What?
Yeah. That's going to be one of those moments that when I'm editing it back, I just shake my head at myself. I was listening to an earlier episode this week for editing it, and you finish a long conversation about something, and then I just go, do you prefer the name Simon or Simeon?
Oh, for fuck's sake, yeah, I heard that.
Listening to it back in the edit, I was like, I can't even remember how I got there. What was happening? God, you don't stand a chance against the King of Thieves with that kind of a brain.
Yeah, like, sometimes I feel like I'm not being yes-andy enough, but then it's just like, what the fuck am I supposed to do with some of these turd balls that are thrown at me?
It makes me wonder if I was listening to it, if I'd believe that none of it's prepped. Like that we don't sit down and go, oh, okay, so we're doing this subject and then we'll turn that into that tangent and that into that tangent. Because I think, why would you just say, do you like the name Simon?
But I don't know. I don't think you could ever plan that. So we're going to talk about resuscitation for about 45 minutes, and then what I think would be a banging segue into the next segment is if you could ask me how I feel about the name Simon. Oh, does that? Because someone in the resuscitation bit's called Simon. No, just plucked out of nowhere. A bit weird if we just ask how you feel about Simon. Maybe compare it to something else. Simeon, not a person's name that I've ever heard.
Yeah. I did see someone dressed as a sim, though, although she was wearing, like, brown dungarees. I was like, that's not...
Simon, Simeon, Sims. This is... There's something there.
There's something wrong in my coding. Sieve tubes. I think it's sieve. Sieve and sim. That's similar.
Sure.
Similar.
Now, I'm going to finish this sentence.
Yeah.
They're specialised for transport. They have no nuclei. They are very tubey. Okay?
Okay.
They have the perforated end, so its cytoplasm in one cell connects into the next cell. You remember what cytoplasm is?
It's the goop.
Yeah, it's the gooey milieu that everything in a cell happens in. Okay. The sucrose, the sugar, and the amino acids are translocated through the cytoplasm of the sieve tubes. Okay?
Okay. Yep. Travels through the goop.
Now, the other cells are called companion cells because they kind of latch onto the side of the sieve tubes.
Like little guide dogs.
A bit, yeah. They
are a whole lot of fun. Prizes to be won. Use your body and your brain if you want to play the game.
Because the translocation requires energy. They attach to the sieve tube and they provide this energy. Okay.
Oh, like a little battery pack.
Yes.
A little robot guide dog. Meet Morp. I am your companion cell. Here, have a biscuit. Let's go. I will guide the way and feed you.
What kind of robot guide dog just hangs out with a living tube?
Yeah, it's not a great job. But then you hear.
Oh, time to be real. Yeah, that's Floem.
What do you mean time to be real?
Time to be real.
Oh, that weird app that all
Get with it, Grandma.
I don't want to do Be Real. Reality's horrible. That's why we invented Instagram.
Yeah. I do always take a Be Real and just be like, oh, God, there's a reason I don't take pictures of my face.
Yeah, I don't understand the point of Be Real.
It stops doom scrolling.
Yeah, but then just don't have an app.
Yeah, but you want to do that, you want to see what your friends are up to, fine, but it's just not endless like Twitter or Instagram or something is. You get your ones for the day and then you stop and then you don't look at it anymore. It's kind of the point of it.
Then what do you do all day?
Well, you go on one of the apps that you can doom scroll.
Yeah, Be Real only works if it's your only app.
Yeah, 100%, yeah. Cool, that's Floem. Any cues?
Are the companion cells very small?
I did have a picture. Let me hold that thought.
And wait, are the sieve tubes moving?
No. Why would they be?
So they're not like guide dogs. They are just battery packs.
Don't put the guide dog thing on me though. I didn't suggest that.
So they're batteries, not guide dogs.
Yes.
Because the cells are staying still.
They're tubes.
Or vending machines. They are literally like a tube, like the underground. They're little vending machines that shloop, shloop, have some energy, run the power. The third rail.
Yes, Laura.
I was on the tube last night and there's this one station, I think it's Embankment, and there's a little kiosk inside the station, like a guy sells crisps and drinks and stuff. And I was just thinking, that is like, I want Pixar to make a short about working in that tiny little box kiosk inside a tube station.
Why?
It's just a cool little...
slice of life.
Yeah.
Bet he sees some people, like maybe...
Yeah, you know? He sees some stuff and he's just underground all day.
Yeah. Mad things.
Do you think he sees the same people all day and makes up little stories about them in his head? I would.
Maybe. Maybe he just sees faceless drones.
Be reeling each other all day.
Yeah, I've just sent you a picture.
Wonder if he looks at them and he's like, are you a Simon or a Simeon? What are you sending me a picture of? Well, you sent me loads of pictures this morning. Have we got to do a picture bit in a minute?
Yeah,
Oh.
yeah. If you could check out Figgy.
Figgy. Okay, so this looks a lot like the sugar canes on Minecraft, if you've played that. It's sort of, there's long green tubes, and then they've got these like sieve plates, and there's a connection to cytoplasm, and then it shows some companion cells, which are like little runner beans up the side of the phloem.
Well, they're part of the phloem.
Yeah, I don't know. Yeah.
Yeah, okay. That's phloem.
Yeah.
Okay.
Okay.
Cool beans. Right, okay. The next one that we're going to learn about is a new type of cell that you've not heard of before, but should make a lot of sense. Put your phone down.
I'm looking at the WhatsApp web like you told me to.
Oh, yeah, actually, go to a Fig A.
Ah. Ooh, Fig A is a golden key with a small blue dot in the top left.
Yeah, so that is a root hair cell.
A root hair cell.
Yeah, it may
Like as
look
in a
like...
hair on a root or the root of a hair?
Well, we're talking about plants.
So a hair on a root.
Yes.
Oh, do you remember in Artemis Fowl, Commander Root?
Yeah.
And Mulch Diggums, he could pull his hair out and put it in a lock and it became the key shape. Cool.
Good books, yeah. What about the butler?
Butler?
Butler, yeah.
The
butler.
Eurasian. That was the first time I ever heard the word Eurasian.
Yeah, it's very vague.
Yeah. I never watched the film in the end, did you?
No, look, dog shit.
Yeah, I agree.
Quite enjoy the amount of media I have for Artemis Fowl, to be honest.
Love
Don't
Artemis
need a
Fowl.
film. Right, what are roots for, Laura?
Keeping the plant steady and sucking up water.
Yep, and other minerals and stuff from the soil. But yeah, essentially gathering shit up from the soil that they're perched in. That makes the roots an
Organ system. Organ.
probably, but the fact that they need to suck up water makes them an think back.
Active. Active.
Don't just say things. Don't just say things, Laura. Think back a bit. Think about the heart. No, think about the lungs and the kidneys.
Exchange surface.
Makes them an exchange surface.
Actually, I would like to call a second look then at whether that was don't just say stuff relevant or not. Because I think I was saying applicable things there.
Organ, yeah, absolutely. What was going to be the end of active?
It wasn't passive. It was.
It makes them
active.
inactive.
No, well, I hadn't finished, and then you said that because
Yeah, that's what I'm saying. What was going to be the end?
An active process.
It makes the roots an active process.
Yeah, they are an active thing instead
Laura,
of a
I know
passive
that we
thing.
have a semi-antagonistic relationship in this podcast, but sometimes I shoot you down for your own good.
No, because a phloem is an active process and a xylem is a passive process.
No, translocation is an active process.
Okay,
Phloem
then.
is the tube where it happens.
Yeah, but do you know what I mean?
Yeah, I know what you mean, but that's like saying your legs are an active process. They're not. Walking and running is.
Yeah, but I just don't think that was a don't just say stuff.
Okay, I'm sorry. I'll come up with a medium. Just stop.
Yeah, that's better.
So they're an exchange surface. So an exchange surface, to be very efficient, needs...
A large surface area.
Exactly. So the roots are covered in these little nosy bonky...
Oh, kind of like villi, but for roots.
Exactly like villi, yeah, to maximise the surface area. So the plants absorb the water from the soil by osmosis, okay?
Yes.
They absorb mineral ions by active transport.
Because they're an active process.
Active processes go on there.
Stuff.
Against the concentration gradient, okay?
No, hang on, I wasn't writing down, I was being smug. They absorb water via osmosis.
Indeed.
Via osmosis. They absorb minerals via an active process.
Why would they need to do it?
They're recruiting. They're out recruiting.
Via an active transport?
Because they're heavier.
No.
Because there's no such thing as mineral osmosis.
No, because
Don't get entropy in minerals.
What a world we'd live in if minerals were something that just didn't have to obey a fundamental law of physics. No.
Yeah, but people don't do it.
What do you mean?
We don't just get in a room and mill about evenly. We go where there's good stuff. Are minerals alive? No. No?
Stop!
What's a mineral? Just an atom of something. A bit of phosphorus. Is that a mineral?
Stop! It's not working.
Yeah. What's a mineral?
Mineral is basically like ions. They're dissolved in the water. They make up stone and stuff, like calcium carbonate or something like that.
Oh, yeah. Sand.
No, that was silicon dioxide.
No, actually, tropical sand is calcium carbonate.
Yeah. Okay. Stop. So the reason why they have to do it via active transport is because the minerals, they have to take up a concentration gradient. There are more minerals in the plant than there are out the plant.
What? I thought that's what a concentration gradient was.
Yep. And if you want to do something up a concentration gradient, you have to put energy in.
There are more minerals in the plant than outside the plant.
Yep. So to get more minerals in the plant, you have to suck them up.
Yeah. Okay.
Yeah. So the root hair cells are adapted for their job by having the large surface area. That's why they've got that little hair coming out of them. Mm-hmm. That increases the surface area. And they have lots of these proteins on the surface to increase the rate of absorption. Okay?
Okay.
They also have lots of mitochondria because they need to release the energy from the sugar so that they can do the active transport.
Oh, God. What's mitochondria again? One?
You know this, come on. It was episode 1.
Ah, that is a long time ago.
Yeah. We've been doing this 6 months now.
Ugh. Yeah. What's a mitochondria?
They make ATP.
ATP!
Literally, they contain lots of mitochondria which release energy. I said that for the active
Oh my God, Ron, I couldn't have been expected to remember ATP.
No, but I just said that in the sentence where you said, what's mitochondria? I think what happened is I said they have lots of mitochondria. Your brain kind of paused there. I kept talking. And then you're like, what? The absorbed water
No, hang on. I'm not down with this. So...
They have mitochondria
Stop
to make
it!
the energy to pump the ions.
Oh, you stop! Wait. Let me. They're pulling all the stuff out the soil. They have lots of mitochondria to... make ATP. out of the sugar that's just being brought to them. They're not making any sugar anywhere. Sugar's being brought via a transport system, and the mitochondria are turning it into ATP. Then they've got the energy right there and then to pull the minerals out the soil.
Yep.
I'm with you.
Do you know any of the things that water does in a plant?
Gives it structure.
Yep,
A
supports the
plant
leaves.
that's dry gets floppy.
Yep, because literally they use kind of the pressure of the water inside them to keep themselves turgid.
Yeah.
There's 3 other things that I'm looking for.
Keeps it cool.
Yep. Cools it down because the water evaporates out of the leaves. And as we've just done in physics, evaporation takes up a lot of energy. Same reason why we sweat, because it takes a lot of energy for your sweat to evaporate. The specific latent heat energy is lost.
Yep.
Did you hear that?
Is that your tummy?
Yeah, my little tumpkin just made that noise.
Yeah. Have you had lunch?
I did, yeah. I had lentil falafels and flatbreads.
That sounds nice.
It was. Lentil falafels are actually a bit of a game changer. I would say better than chickpea.
Whoa. I can't bring myself to make falafel after the most disgusting meal I ever made for Becca and Will at New Year. Horrible.
Do you want me to tell you?
Is there any sort of flushing system? Is there waste product that needs to be removed?
No, but it is involved in the transport of these minerals because they dissolve in the water and then...
Oh, okay. So like mineral transport system. Oh, let your love blow like a mountain.
Nice. And then the last one is it's a reactant in photosynthesis. So it uses water in that process.
Okay. Like when you're getting a photo developed.
Sure. How are we doing for time?
We have been recording for 39 minutes.
Probably... all right, we'll do this bit. We're now going to talk about transpiration.
Okay.
Transpiration is essentially the loss of water through the leaves at the top of the plant. I think we talked about this a bit last time when we were talking about plants. Transpiration is kind of like the sucking mechanism of water through the plant because it has to get used up at the top and then that pulls water up the plant, yeah?
Yes.
You know what capillary action is?
Capillaries are those tiny little veins.
Mm-hmm. Capillary just means like really thin tube, okay?
Itty bitty living space.
Have you ever noticed maybe like if you have a cold glass and there's like some water on the outside of it, condensation?
Yeah, it's a steaming hot day.
And then when that water like runs down and kind of hits the bottom
on a sunflower nearby. Did I tell you about that squirrel that was stealing my sunflowers?
No.
Right. You know squirrels love seeds. Lust for nuts.
This bit next time.
No, we've got time.
No, go on then.
This squirrel in my garden, right, was coming into my garden, climbing up the sunflowers and gnawing the whole flower off the top of its stem and then running away with it.
Mammals be smart, man.
You're very far away from your microphone, Ron.
Yeah, I'm relaxing now. I've gone out of teaching mode.
No, come back. That was it.
No,
That was the whole...
I was on the fence as to whether we were going to do this bit anyway. We'll do transpiration next time when we do cancer and infectious diseases.
Ooh, transpiration. I'm learning, Ron. I've made so many notes.
All right, I'm going to sit back but talk a bit louder.
No, it's bad. And also I can't see you.
Right. Water running down the outside of a glass because of condensation. Have you ever noticed that when it hits the bottom and kind of gets in the crack, it gets kind of sucked all around, and that's how you get rings of water underneath the glass? So that's basically capillary action. When you get down into that kind of small space, the surface tension of the water sort of ends up moving it inherently.
Right. Okay. Love that.
So the xylem inside a plant works as a little capillary. Okay?
Yeah.
So the water will just move up, but you need to get rid of the water at the top to keep sucking it. Okay?
Keep sucking it, sucking it, sucking it. Suck 'em and see. Fisherman's friend.
Okay?
Yeah.
Does that make sense?
No, but I will say...
Well, it's like a straw.
Ah! I fell over. Yeah.
Yeah.
This is a difficult, impossible situation now, Ron, because I will learn that water flums up the xylem, okay? I do not understand what surface tension is. I don't understand why it does it. I never really thought about why the glass was doing that before with condensation on the outside. So I do not understand why, but I understand it's happening.
Surface tension base, I think, exists, because of the intermolecular forces between the water molecules. So essentially, you have them kind of clinging onto each other through these forces. So it's just like a straw. Instead of someone sucking at one end, you've got transpiration losing water out the top.
Yeah.
You've got the surface tension. All of the water's kind of pulling itself up in a chain, and you've got water coming in through the roots.
Yep, I believe you. That's in the business now.
All right. Woo!
I can't do any more than that there, because then you started to explain about molecules kissing, and I was like, why are they doing that?
Yeah,
so it's
I think
another
the
one of those
listeners will
ones
get
that's
it, though,
too
so
big.
we're going to move on.
I got it! Oh my god. Celebrate me.
We have 4 things. We're going to discuss how these change in factors increase or decrease the rate of transpiration, okay?
Okay.
So, how do you think an increase in temperature would affect transpiration?
I think it would increase it because you'd be getting more suck off at the top.
Exactly. More water molecules will evaporate. Anything else you can think?
The water has more energy and so moves quicker.
Exactly, yeah. The rate of diffusion of the water molecules is quicker.
Mm-hmm.
What about humidity?
I don't really know what humidity is. I think that will not affect it.
Why?
Because if there's water in the air, the water in the plant isn't going to get sucked off as much.
Yeah.
So then you're slowing down all the traffic through the plant.
So is that not affecting it?
Well, it depends what the basic rate of transpiration is, doesn't it?
No.
Like, you could say it slows it down, but then you need to know what the base rate is.
Why would you need to know what the base rate is? Sorry, I've got something caught in my throat.
How do you know if it's slowing down or speeding up?
Well...
What's it meant to be at?
Is
normal just at a dry day at 20 degrees?
But no, it's not saying... humidity isn't something that you either have or you don't. We're saying if you increase the humidity, what happens to transpiration?
Oh, slow it down.
Yes, exactly. Why?
Because, like I said, there's wet outside, so you don't need any out of the plant.
Exactly, yeah. Do you want to put that in sort of sciencey terms?
Entropy.
No, concentration gradient, isn't it? The concentration gradient from the leaf to the air is less steep because there's more water in the air.
Yeah.
What about air movement, wind over the plant?
Decrease, because it would be reducing the amount of energy on the surface of the leaf and therefore reducing the...
Why would it be reducing the energy?
Because that's what air motion across does. That's why you have wind chill factor.
No, think about concentration gradients.
Okay.
How would air movement affect the concentration gradient?
It'd stir it up.
I've got a plant. This is a leaf, right?
Mm-hmm.
Pishing water out of the bottom of it. It's very still. The water's just going to go like this and it's going to remain there.
Why?
Because
It's
the air's
fall.
very still.
It's going to fall.
No, it's not. It's water vapor. It's a gas.
Okay.
So there's lots of water here.
Yeah.
What's this doing to the concentration gradient, leaf to air?
Okay, so in that case, then, it's unsteepening the concentration gradient.
Yeah, because there's no air movement, whereas if I've got a through breeze, all that
If it's
water
a dry
vapor,
day, what if it's very humid and there's
even
lots
if
of
it's
air
very
movement?
humid, increased air movement is still going to do the same thing.
Why? Because it would be moving new water into the path of
But
the
there's
leaf.
still going to be water pishing out the leaf. So it's still going to be higher here than it is over there where there's no leaf.
Okay, if you say so.
So
Increase air
I'll answer
movement.
my own question. It increases the rate of transpiration. What about light intensity?
Increases.
Why?
More photosynthesis, so more water being used up in the leaf, so more water needed to be pulled up.
Bang, bang, bang. Done. Nice. That was my tumpkin again.
I don't think your tumpkin likes lentil falafel as much as you do. Oh my god, 2 full pages of notes there, Ron.
I feel like you got that. That felt like the swamp is becoming a marsh.
Yeah. All right, let's check it out. Next after Sting.
Boop, boop.
Right, quizzing time. Hi. Let's do a quiz.
Hello.
Hi.
Let's quiz it up. Can you remember what we were studying?
Don't you know, quiz it up. You got to quiz it up. We were studying plant cells.
We must be the only podcast that has the host's burp on this frequency. Like, you didn't even blink then. You're just like, all right, into the quiz.
because you were talking, so I knew I could just cut my burp out.
Yeah. So you think everyone is burping, but it's just...
Yeah, they just cut them out. I record us on 2 separate audio files, so if one's talking, the other can burp away. I just cut it. Okay. It's only if you burp mid-word and then we need that
Which
word.
we often do.
I think people like it. A lot of the reviews on the old Apple podcasts mention how much the burping makes them listen more. Mm-hmm.
All right. Yep. Okay, can you remember what we were studying, though?
Yeah, plant cells. Plant biology.
Yeah, so we have, for this quiz, 1, 2, 3, 4, 5, 6, 7, 8, 12 points available, Laura. Do you like 12?
Do I like 12? Yeah, I think 12 is a nice number. I love that it divides by 3 and 4.
And 2 and 6.
Yeah, but just 3 and 4 are next to each other, so it's always nice when a number is like a next to each other's numbers.
And there's 3 4s and 4 3s.
Yeah, isn't that what that means, though?
Yeah, it's just nice, though, isn't it?
Yeah, that's what I was saying. It's just, it feels like a nice snuggly buggly. It's like the auntie of numbers.
The auntie of numbers. What are the 2... Name me 2 adaptations of xylem, Laura.
Xylem is waterproof.
That's a characteristic. What's the adaptation that leads to that being the case?
It's made of lignin.
Yes, I'll give you that. It's lignified.
It's a lignifying. Better shape
That
up,
didn't work.
ooh, 'cause I need some xylem. It's lignified. It's got lignified cells, and
And it's full of lignin. the poison for Cusco. Cusco's poison.
that poison. And the other thing is that the cells in it are dead and tubular.
Yes.
The cells have died and made little skeletons.
There's nap all in them. They're empty little tubes.
Yeah.
Yeah, well done. 2 marks.
Yes.
Okay, could you please describe to me, for 3 marks, the structure of phloem?
Phloem. The structure.
I just burped as well.
Stop talking about the burps, and then we can just cut them, mate. You're obsessed with burps. The structure of phloem. Phloem is made up of alive cells that have a perforation in between them.
What's that called?
It's called sieve tubes.
That's not what the perforated bit between them is called, though.
Are you sure?
You'll get a mark for sieve tubes. That is what those cells are called on that side.
Well, I've just put perforation in between the cells. And then I've crossed out guide dogs of the cell world.
Yeah, that was a tangent, wasn't it?
I don't know what the perforations are called. Sieves, just sieves.
Close.
If these are sieve tubes, maybe they've got sieves.
No,
sieve
there's another
cells.
word.
Sieve.
Don't just say stuff.
Civilians.
No, okay.
I don't know.
That's clear.
Okay, so they are connected, and the cytoplasm crosses between the sieve tubes.
Yep.
Then they have companion cells latched onto the side of the sieve tubes that are like little feeding batteries.
Yes. All right. 3 marks for that as well. Ding, da, ding.
Ooh. What were the perforations called?
Oh, sorry. Yeah, 2 plates. You're right. You didn't get that. Sieve plates.
Sieve plates. I haven't written that down anywhere. I'll write that in now. Sieve plates.
I'm increasing it to 16 marks for this quiz, by the way.
Ooh. Because of my sassy attitude?
No.
Oh.
Could you name 3 adaptations of root hair cells?
They have a large surface area, exchange surface.
Yep.
They have lots of mitochondria on the surface
Yep.
for making ATP.
What's the ATP for?
Energy.
What's the energy for?
Sucking up minerals via active process.
Active. Active.
Osmosis?
No.
Active process. Active. Activity centre. Active.
Active.
Salt water. Via osmosis, minerals. Via
Active.
active process.
Active.
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 Yeah.
word.
Active process.
No.
Active. Passive. Process. Active.
Active.
Suction. Active.
Transport.
Nah.
Yeah, I'm sorry, but you didn't get that.
Aww.
That's a phrase that we've used a lot when we talk about like osmosis and stuff. You should have known that, and you could do better than that sometimes.
I'm doing really well today. Actually.
You are. I'm complimenting you.
No, you're not.
I am. I said that you can do better than that.
That isn't a compliment.
That is a compliment. You're
How's
smart.
that a compliment?
You're smart. You can do better, but you haven't.
No, that isn't a compliment. I don't want you to think that if you ever look at Judith, girlfriend of the podcast, and say, you can do better than this, that isn't a compliment. Okay?
That is a compliment. You can do better. You're smart. You're a smart person. You could do better than this. I'm complimenting
That
you,
is not
on how this test has gone.
No.
Okay, right. We're going to quick fire these, okay? I'm going to tell you a factor that affects transpiration. You're going to tell me whether it increases transpiration or decreases it and why.
That was going to be really good until you added that and why. Because I've made good notes on this.
All right. If I increase the temperature, what happens to transpiration and why?
Increase the speed of transpiration.
Ding, and why?
So that would be because water is being evaporated out of the leaves, and so they need more coming up.
And
so the passive transport suckermonoggle is going to happen faster because water's gone, so more soup's in to replace it.
Still true, but and?
What do you mean and? And what?
There's a little bit more.
No, there isn't. That's it. It's increase. Because of...
the evaporation is increased. That's it. But think about, like, everything in the leaf is hot as well.
Yeah. Oh, so it just needs more water to function.
No. What?
Water.
Let's think about the chemistry of it. Almost. Let's think about the chemistry of it or the physics. What happens to the internal energy?
Where did you go?
I'm still here.
Why did you just go in the dark?
I think my phone's corrected. It's very dark in here. My face
Why
is...
don't you turn the light on, you weirdo?
Because we're recording a podcast.
What, and you can't have the light on?
No, it was light when I sat down.
Oh. Sorry. You just look like a creepy little
All right,
boy.
I'll go. Hang on.
Sitting in a cave. Oh, I wish I had someone to whisper the answers to me while he's away.
I've got headphones in.
Oh. I don't know what you mean then.
What about the internal energy of the water in the leaf?
It's higher.
Yeah. All right, I'm going to
what's
give
that
you
got
half
to
a
do
mark
with
because you did get half.
What's that
of
got
it.
to do with anything?
The rate of diffusion is quicker, so the water moves through quicker.
I don't think you talked about that last time.
I think I did. And if I didn't, maybe you should have been okay with it. Increase in humidity, Laura.
That will decrease the level of transpiration.
Why?
Because there's more water in the air, so there's less concentration gradient between the leaf and the air, so less water is being lost out of the leaf, so less water is needed from the stores.
Mark, yes.
Wicked.
Increased air movement.
I remember this one. This one is wrong, but you want me to say that this increases...
If you call this wrong, you don't get the mark.
This increases the transpiration because the air is whisking away the wet as it comes out of the leaf, leaving a dry patch of air there. So the water leaving the leaf has a high concentration gradient, and so
yes,
the leaf is losing lots of water, and lots of water comes
yes,
up from
which
the
is
stores.
true. And why do you think that's not true?
Because I don't think the air coming in is dry and the air leaving is wet. That's too convenient.
But the air leaving is wet because that wetness has come from the leaf.
Yeah, but it might be raining.
Yeah,
And
but you're
there's
doing
more
like fucking right-wing like argument techniques here.
Stop trying to tell people that I'm right-wing.
I'm not.
Podcast.
But I'm saying that you're using like right-wing arguing techniques where, you know, like you go and you say, oh, well, immigration's a net good for society because people are nice and also, you know, it helps the economy as well. And then they're like, yeah, but what if it's raining and they've all got knives? Like, it's not like that. Like, it's just not. And, like, so why are you just picking this weird scenario where, yeah, it might not work in that?
That's just how I feel, Ron.
Yeah.
2 points. Well done,
Yeah,
me.
you can have a mark for it, but I'm not happy about it. Increased light intensity.
Increase in light is an increase in transpiration because the more chloroplasts activity work,
Which is called
photosynthesis,
Yeah.
and that requires water, and so you need more out the stores.
Nice. 7.5 out of 8.
Yeah.
Cool beans. So you got 13.5 out of 18. No, that's not right. 15.5 out of 18.
It feels like I got 18 out of 18.
But you didn't know, so sad. Sorry. Wait, that's not right. Was it even out of 18?
You said 16 originally.
Yeah,
you said
16.
12 originally, and then you changed it to 16.
13.5 out of 16. There we go.
15.5 out of 16 is not bad. There we go, Ron. That was plants. Is that it for plants? Have we got more plants to do?
No, we move on to cancer.
Oh, God. Okay. Well, listen. Hey, listeners, we love you so much. We will be back.
Especially you.
Especially you.
Especially you listening right now.
And if you're currently nodding and just pointing to yourself a little bit with your headphones in, like looking around like, what, me? Yeah, you. We're hiding behind that big thing over there, looking at you, making kissy noises into the frosty air. I realize it's so weird because we are here doing an intro and outro, but we're in the past talking to you in the future.
Always the case.
As of next week, we will be back doing these the week that they go out. So get in touch with us, say hello, let us know how your Christmases and whatnot went, and we will bring you all sorts of banana brilliance. I put the word banana in there. We've been recording for
just
so
weird.
long. Anyway, we love you very much. Leave us a review if you like us. I mean, if you listen to this, you've got some serious psychological issues.
Yeah.
But don't let that stop you from listening. We need the downloads.
No, they all counts the same. Buy some buy some merch if you want.
Woo, buy a hate hat. We will see you next week. We love you. Goodbye.
Cluster Smiths. Put an egg in your shoe and beat it.
Okay.